All right, welcome to Data Hurls. My name is Michael Burke,
And I'm Chris Detzel.
and today we're going to talk about data.
Yeah, I'm pretty excited about that, aren't you?
Absolutely.
It's funny because your expertise specifically, Michael, is machine learning and AI. And so, those two are like intertwined, or at least, when I think about it, it's intertwined. So before we kind of dive into some of these questions, could you kind of talk a little bit about, one, what is machine learning? What is AI and kind of the differences, right? I assume
Yep.
there's some differences there. So can you at least talk about, your thinking around that?
Yeah. So, if you think about AI as artificial intelligence, right? And there's debates over this in the community, right? And then you have machine learning, which is being able to identify patterns in data in one way or another to create value in some way. And AI, where it's really more about a computer being able to make decisions on its own, one could say that those are similar and related because they're both in the same field. But the larger space of all of this is data science, right? Which is
Mm,
any kind of automation or that uses computers to make decisions or identify things automatically. I think that's kind of the general larger sphere of challenges that are within this space of computer science, right?
got it. Got it. So it's quite interesting. When we think about like, data and machine learning, and what I want to kind of talk about today is organizations, big organizations probably, using things like machine learning and how they kind of embed that into the data and how it makes better decisions. Can you talk about, the role of data in machine learning?
You're Yeah, so I
It's a
like to
big one.
always use no, it's actually it's pretty good. It's I like to use the analogy of you're driving a car and you said, "Tell me the role of gasoline or energy, right?
Mm,
In driving a car." I'd say, "Well, that's what you put into the car to make it go." Right? It's the same thing with machine learning, right? The role of data is it's the raw energy that you feed into a model to
mm.
to train it to do things, right? And you can't have a machine learning model without data, right? It's just then a line of code or a set of line of codes, right? And what machine learning does with data is it helps you to identify patterns, to make predictions, right? And the more data that you have, the more accurate and reliable the machine learning model is. And to me, that is like the something that I think at some point, if you have good data, it can't be garbage data, of course, but if you have good data, it will generalize to help solve a problem if you feed it enough. And if you think of something like going back to our other episode on ChatGPT, which I highly
Yeah.
recommend everybody listen to, um, ChatGPT is trained on the internet. That's why it can answer questions in such a broad context where you can just kind of feed it any question and it gives you back some sort of answer, right? It's because it's trained on that much data. And ChatGPT, the existing one, is only a portion of the internet, right? There's still a lot more to learn on. So when we talk about machine learning and what is the value of data, like the more data you have, generally the better. And we're constantly finding new ways to collect and featureize and componentize data to make it usable for machine learning.
So can you talk about that? The different types of data used in machine learning?
Yeah, I mean, so I think that what you are really thinking about is more around feature engineering when you say different types of
Mm,
data. Like
yeah, I think so.
I have data that I want to get into a certain shape or form to solve a specific question, right?
Yeah.
And a lot of this is actually related to what we do in our day jobs with MDMs, right? It's providing clean, accurate, and consistent data. And if you have that and you're collecting the right data to answer the question that you're trying to answer, you'll answer it that much better, right? And so you think about with data, what are the steps that you need to take, right? You have to review and kind of featurize this data. So what does that look like? You have a data, let's say the most common one that everybody starts off on is like the Titanic data set, right? Which is, if you haven't heard of this, it's a data set of all the passengers on the Titanic, and the goal is to predict whether they will survive or not. And it talks about how much they paid for their ticket, right? What floor they're on, what room they're in on this giant ship, where they were, and all of these different features, right? And one of the first things that you need to do with any data set, is evaluate the quality of it, right? So you do things like looking at how many of the records are empty. How many people or passengers, if we're talking about Titanic, do we not have information on, right? Do we have the ages and genders and races and anything else that we've collected? Is it consistently logged and accurately logged for each individual passenger? So you kind of go through this cleansing and quality checks where you try to assess and analyze the data. And then you start to think about featurization and outliers, right? So you start looking at it and say, okay, well, there was this one outlier person who was like in a life raft during the Titanic, before the Titanic hit the ship. And I'm just making stuff up right now, right? But like that guy clearly survived because he wasn't even on the boat. You know what I mean? Or the one person who stayed home, like that's an outlier. And then featurization, that's really trying to figure out, are there other features or ways that we can shape the data to create more meaningful predictions, right? So if we know, already who survived and who didn't from that Titanic data set, well, can we classify or subclassify groups of people? Like maybe it's that we think, all right, there's a group of people that are, younger than 50, and they were just, we think that they're able to just move faster, right? So we make a separate, feature within the data set that says, was this person under 50? And that might provide a little bit more inference to a hypothesis that we have on creating this kind of judgment of what is happening with this data, right? And there's so many ways that you can featurize data. It's definitely an art, and transforming information to fit the needs of what you're thinking is happening within the information, and even automated ways that you can do that where you're not making those judgment calls, all comes down to kind of working backwards from the problem that you're trying to solve.
Yeah, it's a good point. And kind of go backwards here is, to train the model. Can you talk about that? And because something I heard by one of our data scientists once was, training a model takes a really long time, and basically the model knows nothing. So I mean, it starts out at ground zero. And I wish I could remember all the things that he said, but can you talk a little bit about that? Like what it takes one to kind of train the model to get it to where, like a Chat GPT, where it's pretty much scraped the whole entire internet and knows a lot of stuff about the internet. You know what I mean? Like all these things. What does it take to get from zero to kind of that stuff? Just to put it in perspective.
Yeah, absolutely. So there's a lot of different ways that you can train models. And so we can start off with one that is fairly simple, right?
Yeah.
In the healthcare space, there was a model that was trained to identify malignant tumors, right? And so they had thousands of x-rays of people who had these tumors, and they were circled by a doctor who had identified and tested them and said, yes, this is something that needs to be addressed, or it doesn't need to be addressed. And so those labels that a domain expert, a doctor, applied to those x-rays is the training data that then is fed into a machine learning model where it says, okay, I understand that this part of an image is something that is identified with the outcome that I'm trying to achieve, which is predicting these malignant tumors, right? And so using the manpower of all of these doctors who have made these assessments, the machine learning model slowly over time realizes the features, and it starts to value certain features higher than others in an image, right? And it does that because it has all of these labels that these doctors have fed it from things that they've actually tested and confirmed are the thing that the model should be looking for.
Got it. Got it. It starts to learn also, it learns from the patterns, but it also then learns on its own. Like it's seeing other patterns in kind of the x-rays and stuff, right? In some ways.
Yeah. And a good thing to kind of point out is that a machine learning model, a simple machine learning model can only understand based off of the information that you've given it, right?
Mm.
In this kind of classification model, right? Which is what we're talking about. There's other types of machine learning models, and the simplest one would be linear regression, which for those that took math, like it's drawing that straight line that kind of forecasts something, where you say, okay, like I've got a bunch of different stock points on a chart with an XY axis, and I need to predict, maybe it's prices of houses, right? And you can say square footage versus price is like the X and Y axis. You've got all these different data points, and one would think that with a data set like that, as the square footage goes up in the house, so does the price, right? And so the model will look at all those different points on a dot, and it will try to figure out what is the difference between all of these, like the relationships between them. And it does that by measuring this mean error, which we won't dive into in this talk because this isn't supposed to teach you about data science. But essentially what that does is it kind of approximates, it slowly adjusts this line, this linear line, that kind of fits to all of those little dots that are speckled on an XY coordinate. It says, okay, this is the best fit of this line on the chart. And that's how it forecasts when you say, okay, well, I've got a home that has, 5,000 square feet. You draw your line up to that forecast and you say, okay, well, that's going to cost you a predicted value of your home is right around here.
Okay,
and I wish I had a
whiteboard.
Yeah. We
Well,
can do a
this is a
whiteboard session in another one. So
Yeah, and this is a podcast. I mean, we'll do both video and audio, but podcast I won't be able to see
great
it.
call out.
So we'll do video too. So don't
Edit
worry.
this part out. Yeah.
No, we'll keep it. What are some, like, when you think about like data preparation, what are some best practices for data preparation and like feature engineering? Does that make sense?
Yeah. So I mean, the first and most obvious, and this can be an art as you get more detailed, right? Is selecting the right data, right? A lot of times, especially new data scientists will make an assumption early on that they have the data they need to answer a question. And in fact, if they had stepped back and analyzed the problem a little bit more, they would realize that there's a lot of data that they haven't collected that's meaningful to answering that question, right? And I always look back to like my son, right? And he says, I'm hungry, right? Why are you hungry? And the simplest question would be to look at like, when was the last time he ate, right? But are there other factors that are involved in that decision than just the last time he ate, right? Is he growing?
Yeah.
Did he eat a healthy food? What were the nutrients involved in the last meal that he had, right? Who fed it to him? What was the portion size? And all of these things, if I wanted to get an accurate prediction on when he would next be hungry, would probably be factors, right? And it's like any decision, if you start asking yourself the whys about something, you start getting into a whole nother problem space where you say, look, if I really want to answer this question at scale, there's a lot more variables than what I can think about even in one day, of walking through the problem. Like I have to go much deeper into this to be able to seam together all these little bits to figure out what really is that problem. Now, on the flip side, if you've got all of this information on 10 million kids and the data of when they've said they're hungry, well, then it's a lot easier because that data starts to come to some sort of generalized conclusion on when children are hungry, and maybe not just, my son who might just be hungry every time he sees some ad on TV, right? Do you know what I mean? Like,
Yeah.
And so there's that variance there where, volatility ultimately starts to smooth out a little bit as you add more and more data points to a problem. And then, after selecting the right data, I think that we talked a little bit about this, but cleaning and transforming the data, right? Removing outliers, creating the right format, diving into each feature, right? Like, so my child is a certain age, right? Let's say it's 4. And, there might be children in this data set that we're looking at that are, 16 or 17. Are they outliers to the problem that I'm trying to solve, which is for 4-year-olds, right?
Hmm.
Obviously, like removing missing data and then creating additional features, which we just talked about, to answer a question like this are really important, right? And so starting to kind of look at the combinations of things and the cause and effect of certain things will allow you to create more informative features that help train a model faster. So a good thing would be like, let's make the assumption that a child has to eat within a 24-hour period. Well, that significantly limits the scope of a model that knows nothing about how a child eats, right? Or
Mm-hmm.
when a child eats. And so a model might start off saying, like, well, we have data points only once a day, so we think that the child's hungry only at 3 o'clock,
Right.
and that will happen. And that's like the overfitting of, if you have bad quality data, your model starts to overfit to these problems and make assumptions that
Hmm.
are incorrect because the data wasn't captured correctly.
It's just so many issues that could happen, like, even when you think of Chat GPT, it's still humans that was feeding the model from the internet. And you have internet stuff that is completely off or wrong,
Yeah.
anything. So I mean, you know, it just there's just so many opportunities to be wrong while you're feeding this model, training this model, and how you train the model and what you're put. It just seems very difficult to get really good, clean, perfect information from this machine learning piece. Just takes a lot of time and effort, is what I'm hearing, or it
And
could.
think about if you accidentally collected bad information, right?
Yeah, exactly.
I mean, and this is a huge thing that a lot of people in the data science space have brought up with ChatGPT. It's amazing, right? It's got a lot of
Yeah,
potential. But what if you start using it for and depending on it in ways that it wasn't intended, right? Like, should you be making financial decisions off of ChatGPT, right? Probably not, you know. Um,
maybe. I mean, it's probably got some good information around it.
Maybe,
I
but
don't know.
the data also was only trained till 2020, so
2021, I thought.
or 2021. Yeah, yeah.
Yeah,
So you're training off of outdated information, and
yeah,
there are, and I'm not saying that might be a good opportunity. I don't know. I haven't looked into it, but like what I'm trying to say is that, because it doesn't have a clearly defined outcome that people have put controls
yeah,
into and thought
yeah,
about, there is a lot of risk for misuse, right?
yeah,
And misappropriation and misinformation. And there's no way that any group of people can vet the information that's going into that. So the other thing that's a little scary is, well, what if it's collecting bad information? What if bad information is being generated intentionally and fed to
yeah,
ChatGPT? There's all of these things where you realize that the model isn't like this super being.
yeah,
It's something that's just trained to recognize patterns and culminate a response based on those patterns.
yeah. Just brings up so many questions. But let's stay on a couple more, so we'll
Yeah.
stay focused a little bit. As you kind of look at big companies, how does machine learning, how can you integrate that into big companies' existing data infrastructure?
Yeah. That's a great question. I mean, I think that, when you start trying to integrate machine learning, especially if you're a company that's never done
Yeah,
anything in the ML space or AI space, right? There's just so much stuff that needs to get done. And my first suggestion would be, that the scope of that question, Chris, could go on to be something that we do 10 episodes on if we wanted to dive into the details of everything. But, a general principle, if you're starting off, and this is a valuable question, is start very small, right? Like define a very
yeah,
achievable problem and clearly identify and understand the goals of that problem that you're trying to solve for, and how machine learning and the scope of machine learning can help answer those questions, right? Too often you get somebody in the room who doesn't quite understand how these things work, and they have this, big goal that they set out to, which is great. You're trying to, get something done within an organization, but you don't have a full understanding of how the model works, if you have the right data, if you have the right infrastructure. And so I think that like the questions that you want to ask yourself when you're starting off this is getting the right people in the room, right? Do I have the right technical expertise in my organization to even start machine learning? Do I have people who I trust, who are trained, who can develop and implement a machine learning model or project? That includes people like data scientists, ML ops folks, engineers, and even data analysts, right? And other relevant people in that ecosystem that can come together to create that value, right? Especially when you're first starting off, there's so much heavy lifting. It's almost like starting a small mini company within a company, right? The architecture and the infrastructure that you need to build and scale models is not there, right?
Yeah.
It's likely not there. You might have data, but is your data even good? Is it high quality? Has it been engineered with the right features? Do you have the right cloud computation or computation in general to be able to compute a model off all this data that you've collected, right? Who's organizing it? Who's governing it? So I think that, as you dive into this, like you have to ask yourself, do I have a well-defined process, right? Yeah. Have I mapped out all the necessary steps to get my idea, and even if I have my machine learning model, into an ecosystem? And then, after that or during that thought process, you need to ask yourself a whole array of other questions, right? Do I have the right governance?
Yeah.
You're opening the doors of your company to automation, right? And if you think about like an assembly line, you don't just bring one of those AI arms in and slap it down and say, go, right? You have to have a whole process. You have to have governance. You have to have security protocols. You have to make sure that it's operating safely and that it's not going to harm anybody.
When you kind of think about it, I mean, you make it sound a little, be careful kind of thing. And I don't disagree, because one of the things that you hear a lot, and it's right now sexy, is like machine learning and AI. We push that into our products. We push this out. We all need to start doing this machine learning and AI. And now with Chat GPT and then Google trying to come out with their thing, look, it is cool. It is awesome. And the genie's out of the bottle now with Chat GPT. One way or another, like it or not, dangerous or not, it's there. People now can feel it and see it and understand just a little bit about what, these technologies that can do, and you make up a good point. Like some of these organizations that are just diving in, big insurance company, maybe even, government type stuff, these very regulated type, banking industries and things like that, trying to just want to change the world. You got to be careful about that stuff,
Absolutely. And it is a place where regulation has come in pockets, right?
Yeah.
There have been pockets of talking about AI auditability, right? The ability to break down how a decision was made, especially things that really impact people's lives, right? Like in the healthcare space, in the financial services space. You have to be careful. You have to be careful that your model might be doing a great job at answering a question like optimizing whether or not we should give a certain specific person a loan. But what if there's a lot of bias there? What if it just starts excluding specific cities or regions of a city because the probability of default is high, right? Like that, is that really okay to not give somebody an opportunity to have a loan because of other failures in this geographic area? Well, a model doesn't consider all of those things, right? A model is just going to optimize on the things that it weights based off of the one or two success metrics that you feed it and you define to it. And so these are where things start to get a lot more dangerous, right? And you think about in the healthcare space, right? Well, if you're recommending like a process or a medicine, what is the cost of that? If that goes wrong, and I think this is something that we don't ask ourselves enough. We don't ask ourselves when we're setting up a new process or deploying a new model, if I get this wrong, what is the cost to the end user or thing? And that is so important to try to map out ahead of time. And that's like when we talk about operating with ethics and with responsibility, this is where it becomes really confusing, right? Because it's hard to work backwards and understand why a model made a specific decision. There's so many variables that you've plugged into it, you've thrown into it, saying, I think all these things are important. That auditability and unwinding that, if there is a problem that starts to develop, is really difficult, which is why, like, again, like starting super small and with a defined targeted scope will set you up for success early on, right? And you can slowly build that confidence of doing bigger and more risky things as your governance and as your security and all these other attributes and functions that need to grow with your ML evolve, right, and mature.
Yeah, I think you kind of answered the last question was about, how does a big company ensure, ethical use of data in ML? Anything else that you would say about that?
I think the biggest thing is just focus on like really spending the time to train your employees, right? The people that are responsible for these decisions, they're under a lot of pressure. We're all under a lot of pressure to perform, to improve the financials of the companies we work for, right?
Yeah.
Ethics needs to be higher on that pedestal. We need to really be weighting the choices that we make for saying, what is the real ethos of this company, right? Like, how do we want to operate as a business? And there is going to be points in time where you get to these gray areas, right? Where you have to make a tough decision on how you're leveraging data for an outcome. And if you don't have these ethics established, these policies established up front, what option do you think any employee who's getting rewarded for one thing is going to take? They're going to take the one path of least resistance and get the pat on the back, and it's very difficult to kind of unwind that that string once this whole process is kicked off, right? So encourage transparency, conduct audits is another big thing. You should have a process for either internally or even or externally auditing your data and your models. Respect user privacy and understand regulatory guidelines, right? These are huge things. We've got GDPR, we've got California Data Privacy Act. We've got so many new regulations coming in to try to protect consumers from this stuff. Make sure you understand them, because there's also really hefty fines and risks that you take on as an organization if you aren't caught up on these things.
Michael, this is really good. And, this kind of heads us to the conclusion of today's episode on machine learning. So thanks everyone for tuning in to Data Hurdles. My name is Chris Detzel, and
I'm Michael Burke. Thanks for joining.
Thanks, Michael.